Hey guys, it's Mr. Elton here to help you with your homework today. This first part of the video is for those of you who are completely lost, unsure of what you're doing in the whole wide world to solve systems of equations. If you know what you're doing, but you just have kind of a specific question maybe about a certain type of problem, you may want to skip ahead. This first part's going to be pretty basic. Understand when we're solving systems, guys, that we're doing what we've always done. We're trying to get down to a point where we can say, hey, x is this. But in this case, we have two variables. So I have to say x is this and y is also this. And this is really, really easy if we were just talking about one equation. For example, this equation y equals 4x. If I pick a value for x, like let's just say 3, 4 times 3 is 12. And to solve this equation, oh wait, it's already solved for me if I do that. I get y equals 12, and so I know that y is 12. In other words, this is a solution because it makes both sides of the equation equal. If you remember from earlier in the year when we solved equations, we would know we're right if the number that was equal to our variable, if we plug that back in and we got both sides to be the same. So this equation is balanced, this must be a solution. But there's more than one. I could plug in, for example, 4 for x, and then y would be 16, right? And I can keep going on and on and on and on and find a whole bunch, except I'm looking for one solution. But not just one solution for one equation. I'm looking for one solution that works for both equations. So let's just check our first one really quick. X equals 3, y equals 12. If I plug those numbers in over here, 3 times 12 plus 2 times 3, and I'm just going to see if that is indeed equal to 28. Ooh, I get 36 plus 6. I think I end up with 42 is equal to 28. That's not close. That must not be a solution to this second equation. Even though it was a solution for one, it wasn't for the other. And this is where substitution comes in, guys. Substitution is the way in which we solve systems of equations if one of our variables, in this case y, is already clearly defined. If I asked you what y is, you would say y is 4x. Literally, y is equal to 4x. And since this y is 4x, we're going to assume that this one must also be 4x, and we're just going to replace it with 4x. So if I rewrite this second equation, instead of 3y, I'm going to do 3 times, well, what is y equal to? 4x. And then I'm just going to continue to write the rest of that second equation, plus 2x equals 28. And now I have one equation with one variable, and that's totally solvable. It's really easy to solve, actually. I think I end up with 12x plus 2x equals 28. All right, I think that gives me 14x is equal to 28, which would give me a value of 2 for x. Now, be careful. A lot of you are going to get to this point and be like, yay, I got an answer. Be careful. We always need two answers because we have two variables. So if x is 2, how would we find y? Well, the nice thing about substitution is I already defined y as 4x. If you look up here, y is 4x. So if x is 2, what's 4 times 2? The answer to that is 8, and that is exactly what y is. So x is 2, y is 8. We're totally good. Now, I think most of you will be able to figure these out. They're not too bad, but one issue we're going to run into is we're eventually going to get equations where y is not isolated. And if I made you take a wild guess, you might figure out how to do this on your own. We're going to actually have to get a variable by itself from the start. So I'm actually going to solve this equation for y because I need to know what one variable is in order to plug it into the other equation. Right now, I don't know what y is equal to, so I'm actually going to have to solve it. And I'm going to show you how I would do that in this case. I'm going to minus 3x from each side. All right, I'm going to get 3y is equal to negative 3 minus 3x. The last step here is to divide by 3. And when I do that, I will get y is equal to, make sure you divide each term by 3, negative 1 minus 1x, or just x, and that is y. This is what I was looking for, because now that I know that y is negative 1 minus x, I can plug that in to my other equation. So this actually takes a lot of work. is now I need to rewrite my other equation, my first equation, but again, instead of y, it's -1 minus x. And this equation is a bit harder than the last one, so let me just see if I can do a little magic here. Remember, we're distributing -4, not just 4. So I'm going to get -4 times -1 is +4, and -4 times -x is +4x. And let's see here, if I played my cards right, I think I get x plus 4 equals 2 when I combine my terms there. And then if I subtract 4 from each side, I get x is equal to -2. And all of that just to get one variable, but I'm still not done. I then need to take this and plug it back in. And so -1 minus a -2 would actually be -1 plus 2. So y must be equal to 1. If I wanted to take up more of your time, I could go back in and plug each of these into both equations to make sure they work. But I'm pretty confident I didn't make a mistake. I think the solution to the system is -2, 1. There you go. That's how you would solve one that looks like this. Two equations in standard form. Again, you got to isolate one of your variables. Now, I will say this. I could have easily isolated x instead of y. It doesn't really matter which one you isolate. As long as you plug it in correctly into the other equation, you'll still get the same answer. Hope that helped, guys. Feel free to shoot me an email or a question on the class website, and I'm going to do my best to get back to you as I can. Thanks, guys.